Okay, guys, so I think I might have figured out an idea or solution to the Spectrum Analyzer. So this is software that was offered on SDR Play's website. I can't remember specifically how old this one is. Probably 2020. So I was having a conversation with W7WRX about attenuators, RF samplers, and that type of stuff. And so we came to this conversation, and basically what he said was that you could just kind of put the antenna on the Tiny SA, and you should be able to check the output of a radio. But for laboratory grade, you need an attenuator. The problem with the attenuators is that they are expensive. If you're going to test anything more than a couple watts, they're complicated, and it seems like they always have like multiple different connectors. It just seems like lots of insertion issues, like possibilities of failure. I've seen ones that were, failed. So when an attenuator fails, it's going to dump all that RF into your analyzer. So I'm by no means an expert on this subject at all, but like I don't find I often need an antenna analyzer, but I know that I have got lots of radios. I would love to test them and see how they perform. Let me see if I can get this to zoom out. Okay, so we got a radio here. There's the SDR Play over there. And I believe with this, we just click start. And as long as we're fairly close to the okay, I'm trying to remember how to even use this stupid thing. Yeah, it's not what I want. Okay, let's just do okay. We can see it's picking it up. So, if I make an RF tap, I should probably be able to do it with this. So, now this is kind of nice. I don't know how accurate it is. So I've been considering buying the Tiny SA, but I noticed that there's two versions. They all say they have like hardware 3.1, and one of them says 3.1L, and then one of them says, it's 3.1E, and then the other one says 3.1EL, and the date on one of them is like 2021, and then the other one's 2023. But they claim, all the hardware, it's the firmware is all the same, but the dates are different. And one of them is like $61, and it comes with like this little attenuator, and it's an end connector, which is absolutely useless. I mean, I hate end connectors. I don't have anything that uses end connectors except for a watt meter. So now you've got this stupid ass end connector. You need an SMA. Even if you're, I'm measuring HF radios, I need an SMA. Or, because I got to go over to the spectrum analyzer. Anyway, so the thing is, it's 10 dB, and it's like 10 watts or something, or 5 watts. What am I going to do with that? It's 10 dB. Like, you could measure maybe a watt or half a watt, I think. There's a really cool chart on the Tiny SA website. It basically breaks it down to like what you need as far as attenuation. But like I said, if the attenuator fails, you're going to dump all that RF into your unit and blow it up. And so that's not going to be good. Let's move this over here. That's what we're seeing on the Nano VNA transmitting near. Is there like a hold function? Okay. So, what we're looking at here, I don't know what the hell I'm looking at on this. So, anyway, I mean, this is cool, but I don't know how accurate it is. I know people are pretty pleased with the other things. Start frequency, end frequency. Well, this isn't going to do us any good at all. Okay. Let's go. And add another 0. Nope. Where do I go? This is annoying. I know I did this before. And I don't know why you can't just type in the frequency. Okay, so this one here, span, there's an IF frequency that it's using, and so the display scale is at -60 dB or dBm. Okay, now alright, we could go like this. So our start frequency, let's go down to 20 megahertz because we know there's harmonics. Okay, and oh, that's our center frequency. Okay. Our center frequency would be I guess we'll use, so if our center frequency is 146, five, 2, okay, and we'll go ahead and look at it, what it looks like 1 megahertz, but that's not enough. Okay, so we click start. You see all kinds of spikes. Let's go 10. There's something on there right now. Okay, I'm not sure what I'm looking at. We'll go 100 megahertz, so it'd be 96 to 196. But there's all these other things this thing's picking up. How am I supposed to sit here and read what this radio's doing when I got spikes that are at like 95, 92, yeah, 97. What is this? I don't understand. Okay, let's click stop. Start. Maybe it's too much gain or something. Let's see what happens when we look at 1 gigahertz of spectrum. Boy, that's slow. Alright, so that's just too much for me. Where's my gain? Okay, gain. Alright. So we've got some kind of spikes here that this thing's picking up. I wonder if maybe if we put a dummy load on this, if these will go away. That might be a good idea. If I can find it. So something it's if it's gonna do this, I can't use it. You know, that's just not gonna work. Oh man, where did I put this stupid dummy load? The dummy can't find the dummy load. You know, this is how it works. I've got a project I got to do too, as far as dummy loads go. I have I guess it's a bird made by RCA, big huge broadcast 50 ohm dummy load. It was kind that were oil filled, and this guy that we all know had a bunch of them because he does clean up for these radio stations and stuff, and one of them got dropped and leaked, and he was like, "You want it?" I'm like, "Yeah, I'll take it." So I got it for free. So there's no oil in it. And anyway, so it's got some really weird connectors on it. Really weird. Okay, we're transmitting. There's no way we can read that. So the signals on this, I think, maybe are a little too strong. Display scale setting. You know, I don't really know how to use this thing, I'll be honest with you guys. So we've got 100 megahertz of spectrum we're looking at, and maybe that's just like too much for this thing. Yeah, I don't know. So anyway, I'm thinking about just buying one of the tiny SAs. But I'm like, okay, so I buy it. What am I going to do? Prove that all these radios I have laying around here are dirty? Okay, so the problem with 10 megahertz is, like, how wide is a 2-meter radio? And it's pretty wide. So, like, I mean, we're not going to see anything, I don't think, useful on this. So there's some other settings here. Span, sample times per second. Okay. Wonder what it's by default. Okay. Oh, look at that. It just changed. Okay. We're not really seeing anything. So transmitting. Okay. So the sample time has something to do with something. 2 megahertz. Okay, it looks a little quieter. Okay. Okay, now 20 megahertz. Let's see what happens. Now we're seeing a spike again. Okay. So it's hard to see what the hell we're doing, but anyway. So what am I going to do with the spectrum analyzer, guys? I mean, is there any other use for it? I mean, what am I going to use it for? Just to test HTs that I don't talk on, so that I can tell you guys to don't buy any of them, because probably most of them are dirty. Okay, so the sample time. So the sample time seems to be the determining factor of what's going on here. I'm just not really able to obtain a reading, though. So, if I'm to get a reading, this is probably it. And we have no idea if we're doing this correctly. That's the problem. So, if you're looking at the 100 megahertz of spectrum, and we went to 10, it's just changed our center frequency, which I'm not sure why it did that, because it shouldn't have. So none of this is actually any good anymore, because we're not even on the frequency that we need. Okay. So for 96 to 196, they want to be. So if we're looking at, it says 2 megahertz, they would be looking at 145.52 to 147.52, and that's just a 2 megahertz sweep time per second. Okay, so the faster that is, I guess, you know, the easier it would be to read it. So let's see what we get. It looks about right, doesn't it? Okay, so that's a Quansheng EVK5. Okay, I think those are dirty. Let's see. Let's get something that we know is dirty. Okay. Dude, that thing's clean. Look at that. And not only is it clean, but it's like way up there. Okay. This is pretty cool. Okay. Look at that. Chest. Why is this thing? It says it's on AM. Now, I don't think this thing transmits on AM, does it? Let me go up to the next thing here. I really wish they could have just gave this stupid thing the extra buttons. Nope, that thing's dirty. Okay, so we're going to test all these radios really quick on Simplex. Okay, I want to test this one just because it's newer. Okay. I just wish they could have put extra buttons here so I don't have to go into a function menu to go into VFO mode. The frequency step is so crazy. Dirty. Okay. Alright, so now we've got this other Baofeng. This is really old. Okay. It's not changing. Interesting. Oh, you know why? Because it's locked. Because. Okay. Ooh, wee. That one's dirty. But, so it seems to be, depends on where you hold it. Okay? That looks normal. You see a spike over here. If I get too close to it, it looks bad. So, I really don't think that this methodology would even work. Okay? See where that one's at? You put it near it, it seems fine. Okay? There's a spike right there, though. And we can see it. So I don't know if this is any kind of...
Welcome. Channel mode.
I don't know if it's legit to do this.
Frequency mode. 14652
Okay. So all of them seem to do that if you get them near it while it's transmitting. So I don't know how you could test like this. Because if the signal's strong, it shows that it's got spikes.
4, 3, 2, 1.
Alright. Interesting how the one Bofang, though, right next to the connector, looks good. Okay. Now, that's the Radtel. Okay. It's possible there's some kind of modulation in there. We can see our frequency right here too. That's pretty cool. Let's try the other one. Oh, I left the other one on. It's dead. We'll have to come back to that one later. So, if you went and you bought the attenuator and you bought all that stuff and you bought a tiny SA, and then you went and just did basically this with all the radios that you own, I think there was one more I hadn't tested, or two more.
Sounds like we're on a similar kind of system.
Okay, I get it. Deal with the radio that's trying to fall over.
878 2 plus all those numbers that they put on behind.
Okay.
And running off of
So I'm on DMR right now. I just gotta go into my zone. This is what I like about these type of radios. Go into your zone list, and then I can click whatever I want.
2022.
And each of these zones has different things.
And
I've got a thing for sending text messages,
first, then I passed the
satellites,
call,
MERS.
which I got the notification and my call sign for both of those on the same day in May. And then I got my extra.
Okay.
One.
I don't know if I have a simplex frequency in here.
12, 11, 10, 9, 8.
So this is why I like these.
7, 6.
I mean, you can use this. Actually, you can't.
6, 5, 4, 3.
Okay. And that's right near the connector. So I think if we see how high the signal is, we realize that maybe there's just too much signal. So if the signal, I think, is too strong, then you start to see these other hairs raise up. So, I don't know what this is. Sweep time. 2 and 5 and 20 and 50. Okay. So you can change some things. And you need it like, so the sweep time changes what you're looking at. But if I'm looking at it like this, and I get near it, it changes. So that's 500 kilohertz. So what we're looking at was 2 megahertz. But we're off the scale. So, display scaling, reference negative 60, range 100 dB. Let's go 140. But that just brings it up. Okay, so the display scale at 140. Interesting. So that's 140. Okay, so and it was what, at 100 before? So what should it be at? That's not 100. So does it mean it's going 100? Range of dB. We'll go 90. So now we're not doing anything useful here. Let's see what happens when we hit 40. So 40, we're like unable to display anything. 50, same thing. Let's go 80. So 80 is, we're starting from like 140 to 70, which is really only about 70. Okay, I see now. So if we are at 140, it puts this thing up here, but why is it at between 130 and 140 is beyond me. The reference dB is 60. What happens if we put 100? It goes up. The reference dB, and if we went 0, it would be right here. I don't know how this works, but what I'm seeing is we're maxing out on the scale no matter what with a little radio. And this is me away from it. So anyway, I know some of you guys know a whole lot about this, so leave the comments down below and we can figure something out here and I can learn something. This is definitely interesting though. The reference is 0. So this line is just sitting here at negative 80, between 80 and 70. And our range is 140. So we like 0 right here and 140 here. Let me see what happens if we go. Okay, let's go all the way. 180. So 0 to 10, they don't show the 0 mark for some stupid reason. They don't show the 180. We're still sitting here between the 70 and the 80. So if our reference is 0 dBm, if it's negative 100, it moves us up. or it changes the numbers completely. So negative 100, are we still at 180? So 180 plus 110 is 290. Yeah, I guess we are. So I'm not sure I understand what it's doing here. And if we go 20, it's all positive. So what happens if you click that then? Okay. We can actually see the scale. So I'm actually right at the connector. So that's negative 80 right there. Our reference is 20, which probably should be 0, right? Wouldn't that make sense? Okay, so the reference is 0 dBm. And so from the top is negative. I don't understand the scaling of this thing or how it works, but that's what that looks like. So let's grab that one. Okay. We can see this one puts out a lot less power, and that's why when we tested it the other time it looked clean. So anyway, guys, I'm gonna fiddle around with this for a little bit. Maybe I'll order a spectrum analyzer. I don't know. I just other stuff I need to get done, and money's really not really there. I had like $12 from Amazon to knock down the cost. So not enough revenue coming in from Amazon on affiliate links to really buy anything to do experiments on the channel. One of the things I do want to do is I do want to build an RF tap, and what that'll be is kind of like a line section in a meter. We'll find a junk toroid in the junk box and wind a coil around it, and then put a resistor across the coil, and then put one part of that to the ground, and then we'll put another thing. And I've watched a couple of videos on doing it, but what I used to do is, and somewhere around here I have what people used to call a gimmick. You would take like a piece of coax and just wrap coil of wire around it, and then hook it to your oscilloscope to kind of look at the waveform as a novelty. So I'm going to make a tap for doing that. I feel safer using a tap than I do attenuators. So anyway, we'll catch you guys later.